Hello, this is Ms. DB, and in this video we're going to learn how to do some of the problems in the Chapter 8, Section 5 assignment. We are going to be using more trig. This time we're going to use the law of sines and the law of cosines, some new rules, some new formulas to solve triangles for missing side or angle measures, and we use these when we don't have a right triangle. So up until now, we've had the Pythagorean theorem, we've had sine, cosine, and tangent. We've had different ways of finding missing sides and missing angles in a right triangle, but now we're going to learn how we can do it with a non-right triangle. So it's important that your calculator is working out. I have a website here of one that I found online that's pretty good. And it's over here. It's kind of wide. It takes up more room than my other one did. But what I like about it is if I want to find the sine of 30, I can type sine first and then the 30 and hit equals, and it'll do the answer. I don't have to work backwards like I do with the one that's on my computer. So that's pretty nice. What I also like about it is that the inverse sine, the inverse cosine, and the inverse tangent are right here on the screen. You don't have to find another menu somewhere where they might be, a second function or to switch it to those inverses. And the other thing I like is that it tells you right off if you're in degree mode, or you can switch it, of course, to radian mode. Many students get these questions wrong because they're in radian mode, which is the default for a TI-84 for some reason. We want to be in degree mode. So this is a pretty good calculator. It's right here if you don't have a good one. You can also use any handheld scientific calculator that has sine, cosine, tangent on it. And of course, your graphing calculators work as well. You just have to change it to degree mode first. So here's how you check. If you take the sine of 135, you better get 0.707106 when you use your calculator. If you don't get that, then you're in the wrong mode. For example, let's say that I was using a TI-84 or any calculator and I forgot to change my mode or make sure my mode was in the right, was in degrees. So I would go sine of 135 and hit equals, and I got 0.088. That does not match what they got in this example. If it doesn't match, then you have to check and change this. There's a video in your folder on how to change a TI-84 or TI-85, whatever you have, into degree mode. It's not as easy as just clicking a button like it is on this one. All right, so now that we know we're in the right mode, we can go ahead and look at these problems. So the first ones are just to use your calculator to find the trig ratio and round to the nearest thousandth. That's another thing I want to look at. Let's look at the tangent of 99. Tangent 99 is equal to negative 6.31. Oh, I don't even have to round that one. I think on here they have a way for me to set. Yes, so it's rounding to 2 places. I want to change that to 3 places or more. So let's try that again. The tangent of, that's another reason that this is a pretty good calculator. It will round for you. So now we can see that that was rounded already. The whole tangent of 99 is negative 0.63137515. And if I had more place values, it would go even farther. It's a non-repeating decimal. But if I only want 3, then you can actually set that on this calculator to only be 3 decimals, and it'll round it for you. So it should be negative 6.314. But some people forget how to round and might round that as negative 6.313, which maybe doesn't seem like a huge deal, but if you make a rounding error and then carry it through a problem, then that rounding error will be compounded and make other parts of the problem wrong. All right, so you're going to go ahead and use the calculator to answer these questions. Next off, we're going to use the law of sines. This is the law of sines right here. For any triangle ABC with side lengths A, B, and C, the sine of angle A over side A will be equal to the ratio of the sine of B over side B, which will also be equal to the sine of angle C over C. You just pick whichever two work for your problem. And you set up a ratio, and then you solve the proportion with cross products. There's an example there. I'll let you look at that. And then here's the law of cosines. It's a little bit different. Instead of using ratios and proportions, there's an equation. So for the law of cosines, there's 3 equations, but that's just because there's 3 sides on a triangle. You really just need the first one. A squared equals b squared plus c squared minus 2 times b times c times the cosine of a. So this one, you need to make sure that when you're looking for a squared, little a, that's side a, you'll be using the cosine of the angle opposite it. And then you'll be subtracting 2 times the other 2 side lengths times that cosine. There's also some information here about when you would use which one. So these next 5 problems are just, you're going to write law of sines or law of cosines depending on what you're given. So in number 7, it says you're given 2 sides and the included angle. So let's look and see which one would work best. 2 sides. So the first one's about 2 angles. That doesn't. Then it says 2 side lengths and a non-included angle. So that doesn't seem to fit. For law of cosines, you can use it if you have 2 sides and the included angle measure. It's exactly what number 7 says. So this then would be law of cosines. Copy and paste it. And then for number 8, it says 2 angles and the included side. So I don't see exactly that up here, but I do see that under law of sines, it says 2 angle measures and any side length. So that should work then, law of sines. So I got to get rid of the co. And then for 3 sides, well, that appears right here. Now look at number 10. Instead of telling me what I have, they give me a picture. Well, what do I have? I have 2 angles and a non-included side. So you look up there and you find which one has 2 angles and any side length, right there. And then for 11, we have 1, 2, 3 sides, no angles. So if you have 3 sides, it's law of cosines. So those are easy, you just list down what it is. Now we get to the fun stuff. We're going to use the law of sine, so now we get to actually do it. So I'm going to use my pen for these. You may want to, you can type them, that's fine, but you may want to write your work on another piece of paper and attach it. They do get a little long. All right, so I want to use the law of sines to find what they're asking me to find. They're asking me to find side BC, which is right here. I'm going to call that side A. And the reason I'm calling it side A with a little a is because it's opposite the capital letter A for the angle. So you are also given the measure of angle A, that's good. We're given the measure of angle B, and we're given the side opposite angle B is 25. So I'm going to use these 2 parts of the formula. So I'll write that down. Sine of A over A equals sine of B over B. And then you just put all the parts in, cross multiply, and then you'll get your answer. So I don't think this one's too hard, so I'm not going to do all of it for you, but I'll set it up. So this would be the sine of 71. Now one thing to remember is that don't find the sine of 40 right now and plug it in. Go ahead and do your cross products and all of it, and then find what A is equal to before you start using your calculator. So now you'll divide by the sine of 71 to get A by itself. Whoops, sine of 71. Now you get your calculator out and you type in 25. Oops, I'm going to clear this out here. Move over a little bit. I'm trying to get just a little bit more room here, but it's not letting me adjust it because I'm recording. That's all right. So I'm going to clear this. There's my clear button. Okay, I think we can see the whole thing now. And I'm going to take 25 times the sine of 40. And it's got a parentheses there, so I'm going to go ahead and close it. And then I'm going to divide this by the sine of 71. And let's just check and see. We've got 25 sine of 40 divided by sine of 71. And I've got in 3 places, I've got in degrees, so this should work. My answer is 16.996, so almost 17. And does that make sense for this problem, for this side? It seems to. The side opposite was 25, so it's in the same kind of range. So then that's what you'd have for side BC. All right, I said I wasn't going to do the whole problem, and then I did. Let's look at one that doesn't have as much stuff labeled for you, like number 14. So in number 14, there's all right, so let's look at 14 because it doesn't have all the A, B's, and C's in it for you. And I've got the formula here again. You can pick any side to be side A. I know they say S, T, and U, but that just means that you're going to take, let's use a pen here. Let's say we use the sine of S over side S will be equal to the sine of T over the side T. So you don't have to have A, B, and C like it does down here. So here's the sine of S, and here's the side S. This would be side S. Here's the angle T, and here's side T. So they go opposite each other. So let's see if we have enough information here to find the measure of angle T. Sine of S, well, that would be the sine of 61. And side S is 8. And sine of T, we don't know T, so we're just going to write T. And side T would be 2.8. So you're going to cross multiply again. And the only thing that's different in this one is that T is an angle, so we're going to be using inverse sine to find what its measure is equal to. So you can do all of the stuff on this left side here on your calculator. You can go 2.8 times the sine of 61, and then I have to divide that by 8, and that's equal to this number, 0.306, approximately. Let's change that to more places. Oh, it won't change it retroactively. So 0.306 is approximately what sine of T is equal to. To find T, you have to take the inverse sine of the 0.306. That's what T will equal. So the inverse sine is right here of 0.306 is equal to about 17.82. Now I'm going to really quick redo this multiplication, the 2.8 times sine of 61, and then divide that by 8. I want to see if it matters if I change it to 7 decimal places. So then when I take the inverse sine, I'm going to put all of that in. 0.3061169. 17.82. Didn't change much. So I'll say that this angle is 17.8 degrees, and that makes sense because that's a pretty small angle over there. All right, let's do one of the cosine ones, law of cosine. So to find the law of cosine, you're going to use one of these equations. It looks kind of like the Pythagorean theorem with this extra stuff after it. So to find, in number 15, to find side YZ, that's this side over here, that would be side X because it's opposite angle X, and this would be side Y because it's opposite angle Y, and this would be side Z. So if I want to find X squared, I'm going to find X, so I want to set it up with X squared equals, now use your other two side lengths squared, so that would be Y squared plus Z squared, minus 2 times the B and C are the same variables that you just used, so y and z, and then cosine of A, which is the angle opposite the side we're looking for, so that would be cosine x. So now I'm going to replace x, y, and z with the parts, the values that are given in the problem. So x squared is, that's what we're looking for. Y is 7.6 squared, don't forget to square it. Z is 4 minus 2 times y is 7.6 again. Z is 4 again. Cosine of 52 degrees. Now don't find the cosine of 52 right now. We're going to do all of this on the calculator, if our calculator is good. All right, so 7, I'm going to clear all this out. 7.6 squared, where's the squared button? There it is. Now you could do it step by step. 57.76 plus, I know that's 16, minus, that would be 2 times 4 is 8, so I'd have to go 8 times 7.6 is 60.8 cosine of 52. And then you can add this together and subtract this. Let's do that in one step. So we have 57.76 plus 16 minus 8, oops, not 80. Is there a back button? Delete. 60.8 times the cosine of 52. So let's look at what we got here. I'll get that plus that minus that. This should be what x squared is equal to. So x squared equals 36.32778 and so on. Now we have to take the square root of that. There's two ways to do that. I could take the square root sign and push the square root, and then I could type all that in again. I could type the square root of the answer, which is even easier. So it saves that last answer for me, and I can take the square root of that, and I get 6.03. And that's what side YZ was. So we did number 15. And then number 17, we don't have any angle measure. So in that one, at the end, we're going to have the inverse of the angle. We'll have to find that to find the angle. So it doesn't matter how you start this one. Well, we're looking for I, so we'll start there. So that's I squared will equal, this is side I, this is side H, and this is side J. So I squared will equal J squared plus H squared minus minus 2 and then J times H, and then the cosine of angle I. So this I matches the capital letter I. So then we plug in all the stuff we know, and we don't know capital I. So when we're all done, we're going to have to use the inverse cosine to find our last part. So I squared is 74.2. J squared is 43 squared. H squared is 35 squared minus 2 times 43 times 35 times cosine of I. All right, now we are going to start simplifying. So 74.2 squared is equal to 5,000. These are some big numbers. And then 43 squared is equal to 1849, 1849. 35 squared is equal to 1225. And now I'm going to do this part, 2 times 43 times 35. $3,010. And then I have to write after that the cosine of I. I'm going to add these together and then subtract that answer from over here. So 1849 plus 1225. 3074. So I have to subtract. So I have to take 5505.64 minus, oops, I got an error there, 64 minus 3074. And that's 2,431.64 is now equal to negative, don't forget the negative, cosine I. Now I divide both sides by the negative 3010. So I'm going to take my answer and divide it by, where's the negative sign on this one? Some calculators have a sign just to mean negative, and some don't. And I haven't used this calculator very much before, so I'm not sure. I don't want to use the minus sign if it messes it up. So I just know my answer is going to be negative. Negative 0.8078538 is equal to cosine t, which means that t is equal to the inverse cosine of all of that, negative 0.087853.8. Now, if I would forget the negative, I'd get the wrong answer for this. Delete. I'm going to take my answer times -1. Does that work? Yeah, okay. So there's my answer, and I want to take the inverse cosine of that. So I want the inverse cosine of my last answer, which was the negative 0.807, and so on. And then I get 143.89 degrees for angle T. If I had forgotten the negative, if I took the inverse cosine of 0.8078, this would be quite wrong. It'd be 36. And then when you look back at your picture, if you got 36 for an answer, you'd be like, how can that be a measure, that angle be a measure of 36? It seems way too small. That's an acute angle, and this is clearly obtuse. So you can kind of double check yourself and see if you forgot a negative. And then on 18 and 19, you only have to pick one or the other to do, and you'll find more than one missing side. All right, thank you, and have a wonderful day.